So in this video, we're going to be talking about the rates and ratios thing. We've technically left off on this right before we had spring break, but I just wanted to go back and make sure that we all had the same thing. So in 7.1, they talk about rates and ratios, what they are, what they do, that sort of thing, and how to use them. We don't really get into solving them until 7.2 and 7.3 because we need something called a proportion in order to do anything with them, really. So it just kind of sets it up. Here's some vocab. I know nobody likes vocab, but we got to know what we're talking about because otherwise words don't matter. Anyway, the word denominant here. It's a very old word, I guess. It's a $10,000 word. Basically, they're talking about what type of measure is it. So, are you measuring in miles? Are you measuring in centimeters? Are you measuring in cubic feet? Or what is going on? The reason why this is important is because if you're trying to subtract two things, they need to be like denominants. They have to be measuring the exact same type of thing. You can't say go 5 miles and subtract off 18 feet. There's no number that represents that. So it's a little bit funky that way. Ratio, meaning to compare two things that are of like denominant numbers. So, for instance, 4 feet to 3 feet, 6 inches to 15 inches, something like that. A rate compares two unlike denominant numbers. This is the one you're most likely to see out in the real world on a daily basis. Things like miles per gallon, your mileage. So it would be another one might be dollars per pound, dollars per ounce, that sort of thing. Those are rates. It's how much does one thing change. In a sense, it's a measurement of how much something changes as a result of another. And so that kind of relates the two unlike terms. Out in the real world, typically rate and ratio, it's kind of the same thing. We separate them here in math, but most everything that you're going to deal with is dealing in rates. The ratio thing doesn't come up very often. So, anywho, I thought I'd go ahead and include some of the other pieces in here. They're not as critical, but the is to. So, and this is, it's going to make more sense in section 2 when we talk about proportions. Blah, blah, blah. But, sorry. But it is its own thing. So when we say is to, we're talking about a ratio or a rate. So the example here would be 12 miles is to 3 hours. Okay, if we wanted to write that as a fraction, we would say 12 miles is to 3 hours. My apologies. I'm trying something a little bit new with this stylus, and so it's still getting used to it. Okay, so we were tasked with some of the later ones to go ahead and put them into simplified fractional format. The first one is kind of already there in a sense. This is called a unit fraction where one of the numbers is the number 1. So this would be a unit conversion from centimeters to inches. We'll study this when we get into Chapter 9, when we talk about geometry and then conversions of U.S. measurements and metric measurements. So it wants us to put that into a fraction that's reduced. Well, in a fraction, we don't really want a decimal. So I'm going to start by multiplying by 100 on top and bottom. What this is going to do is this is going to change the decimal out to a whole number. 2.54 times 100 is 254. You can confirm that in your calculator. And then 1 times 100 is just simply 100. From here, we can divide by 2. And so the question is, well, couldn't you just multiply both sides or both top and bottom by 50? Sure, if you knew it was going to work. I didn't know it was going to work, so I'm just going to go this route. So I'm going to divide by 2 top and bottom. This is going to reduce it down. 250 is 125. Half of 4 is 2, so it's 127 centimeters per 50 inches. Now 50 is only made up of 5s and 2s. 127 cannot be divided by 5 or 2. So this is reduced, technically. In practice, this is the quote-unquote reduced fraction. It's just the easiest conversion. All right, next one here. 105 hits to 315 bats or at-bats. Notice they even forgot the is in these circumstances. 105 hits is 2. Yeah. Well, you can see just how lazy we get right off the bat. 315 at-bats. So you're by and large going to completely ignore the denomination here as far as what type of measurement it is, and you're just going to concentrate on the numbers. So I'm going to start by dividing by 5 and see what happens. 10 divided by 5 is 2. 5 divided by 5 is 1, so this is 21 hits. And then on the bottom here we have 30. It would be 6. 30 divided by 5 is 6. 15 divided by 5 is 3, so this would be 63 at-bats. If you don't know this next step, just reduce them by a factor of 7 or 3, because both 2 plus 1 is 3, 6 plus 3 is 9. Both of those being divisible by 3 mean that 21 and 63 are in fact divisible by 3. I'm going to go ahead and make the jump though, because I recognize this. I'm going to divide by 21. That's going to give us 1 hit is to 3 at-bats. So you're running about a 333 average. That's not too bad. At-bats, not at-hits. Bats. So apparently for every 3 swipes, you hit 1 bat. I don't know. Maybe we were playing, tennis with a bat in the house. 81 to 19. 81 to 19. Well, let's see. 81 is made up of 3s. If you did their prime factorization, you find out that there's 4 3s that make up 81. 19 is prime. It's done. Done. Now, these are called pure numbers. They're not measuring anything. They're not counting anything. They're just there. So they have the same denomination as far as what their measurement is. So you don't have to worry about that aspect of it. This is one of the reasons that points out one of the good reasons, though, why when we talk about proportions, I'm going to say as long as your denominations match up top and bottom, then we're just going to completely forget about them and deal with the numbers, because to follow the denominations through the process, it looks really, really strange. So we just kind of forget about it. All right, this was 7-1.